Hello students, welcome back to my YouTube channel Data Shah. In this lecture, we'll be talking about partial pivoting. So, what is pivoting and why pivoting is required and what are the various kinds of pivoting. So, partial is one of the kinds and the other one is full pivoting. So, first of all, what is pivoting? Actually, pivoting is a process which involves the interchanging of the rows having the zero pivot with one of the rows below it. So whenever you have zero in the pivot element, so we can't have it, right? So that's a drawback when we are doing the Gauss elimination method. So pivoting is very important concept when we are talking about the Gauss elimination method, because there you can perform the partial pivoting and the full pivoting. So this is one of the major drawbacks of the Gauss elimination method, in which division by zero is not possible. So to avoid that, we use pivoting in the augmented matrix. Okay. So while we are performing the first step, that is the forward elimination. So now, what is partial pivoting? Partial pivoting is you need to select the element. Let me just write in partial pivoting, we select the element whose magnitude is maximum. Maximum means we are talking about the absolute value. So the absolute value is maximum. So in partial pivoting, we select the element column wise. So we select the element whose magnitude is maximum column wise. So while selecting the pivot element, you need to check whose magnitude is maximum uh, as a pivot element. And if you need to interchange the rows, you will be interchanging the rows as well. So this process is continued and repeated until you get the desired solution. So let us consider a question. So let me just write the question. Solve the equations using Gauss elimination with partial pivoting. So the equations that is given to me are, so 4 unknowns are given to us in this question. So here you would notice that in this, the coefficient of W is 0. Here the coefficient of X is 0. Coefficient of Z is 0. Coefficient of Y is 0. So when we'll be writing this in the form of AX is equal to B, so it would be the coefficient matrix of 4 cross 4 matrix 1, 2, 0, minus 1, 1, minus 1, 2, 0, 1, 3, 0, 2, 1, 0, 3, 1. Your capital X would be now X, Y, Z, W. B would be 3310. So this is our AX is equal to B. Now, consider the augmented matrix, and then we'll start the partial pivoting there. So let me just write this. 1302, 1031, 3310. Now, to apply the partial pivoting, remember we'll be talking about the first column. So in this first column, check for the element who has the maximum magnitude. So absolute value we'll be finding. So here you could see the elements are 1, 2, 0, -1. So -1 absolute value would be 1. So which element is with the maximum magnitude? That is this element 2. So we'll be considering the element here as the pivot would be 2. So we need to take this element to become this pivot. We have to take it to the first row, first element. So you have to interchange the rows. Now, as A to 1 is of maximum magnitude, so interchange the rows 1 and 2. So after interchanging the rows, I am getting this as 2 minus 1, 3, 0. This becomes 3. Okay, so 1, 1, 1, 1, 3. So rest of the rows are same. So I'll just quickly write it. Now, what is my pivot? This is my pivot. This has become my pivot. So there is no change. Now you will apply the normal Gauss elimination method. That means you have to make transform this into a upper triangular matrix. Okay. So now notice this element is already 0. So you just need these two elements to become 0. So for that only we'll be applying the elementary row operations. So my row operations would be R2 goes to R2 minus which element I have to make 0? That is 1 upon the pivot element into row 1 because a pivot element is in row 1. Okay, I'll write this as A21 upon A11 R1. So, and R4 minus A41 upon A11 R1. Okay. So when you will write this is nothing but half of row 1 and this is R4 minus this is minus 1 upon 2 row 1. So that becomes a plus. Okay. So this will become a plus. So now moving ahead in when you will apply the elementary row operations, first row, no change. So this becomes 0, this is 0, this is 0. Now let's come to the other elements. Now how to deal with that? 1, this is 1, minus half into minus 1. Okay, this element. So this is 1 plus half. So that's 3 by 2. So 1 minus 3 by 2. So that's minus half. So this is just 1. This is 3 minus 3 by 2. So that's again 3 by 2. So this is the second row that we have found. Now the elements of the third row, no change. So 0, 2, 0, 3, 1. No change in the third row. Fourth row, I have made this 0. So 0 plus half. This is R4 plus half times row 1, right? So this. So 0 minus half. So this becomes minus half. 2 plus 3 by 2. So that would be 7 by 2. This is 1. This is 0 plus 3 by 2. So this is 3 by 2. So this is what I'm getting as my new matrix, augmented matrix after the changes. Now, let us move to the second step here. Now you have the first column, you have done the Gauss elimination method and all of the elements below the pivot element are 0. Now, what we have to do, now you have to make these zeros. Okay, so now what we'll be doing, leave the first row and the first column. I'll be talking about the second column. In the second column, which pivot element you will be taking. Now to take the pivot element, I need to select the um, maximum magnitude element. So what is the maximum magnitude element? 3 by 2, 2 and minus half. From these only I'll be selecting. So out of these, which is the element which is of maximum magnitude? Obviously 2 is the element with the maximum magnitude. So again, I'll be interchanging them. So let me write this as A32 is of maximum magnitude. So interchange row 2 with the row 3 to make it pivot element. So here also to make it pivot element. Okay. So now after interchanging the rows, I'll be getting here. I'll quickly write this 2 minus 1 3 0 0 2 0 3 0 3 by 2 minus half 1 minus half 7 by 2 1, and these are 3 1 3 by 2 3 by 2. So we can cross check. This is what I'm just interchanging these two rows. Swap, right? You'll be swapping these two. So after this, the same steps. Now you will be considering this as the pivot element, and you will be making the elements below it equal to 0. That's the normal Gauss elimination method. So take A11 as, which is 2, as the pivot. And you have to make A21, A41 as 0. Okay. So same step here. Take A22, that is 2 as the pivot, and make A32, A42 as 0. For that, you need to find out the elementary row operations. That would be R3 goes to R3 minus the A32 upon the pivot element into row 2. So that's nothing but A32 is 3 by 2 upon 2, so that becomes 4. Similarly for row 4, so this is what we are getting. That's minus half, so it becomes a plus 1 upon 4 R2. I hope this would be clear that how we have formed these two elementary row operations. Now, after this, my augmented matrix would be the first two rows, there is no change. So minus 1, 3, 0. So 0, 2, 0, 3, 3, 1. Row 3, now I have to make these two 0. So talk about these elements. What would be these elements? Okay, so how to find that? This would be minus half minus 3 by 4 into 0, because this is a 0 element. So this becomes minus half. Similarly, this is 7 by 2. There is no change. So after that, this would be 1 minus 3 by 4 into 3. So that's 1 minus 9 by 4. So that becomes 4 minus 9 by 4. That's minus 5 by 4. Okay. And 3 by 2 minus 3 by 4 into 1. So that's 6 minus 3 by 4. So that's 3 by 4. Similarly, in the bottom, I'll be getting a 1 minus, that's plus 1 by 4, sorry, into 3. So that becomes 7 by 4. And 3 by 2 plus 1 by 4. So that's again 7 by 4. So this is the matrix after all the calculations. Now, have we achieved the upper triangular matrix yet? No, we haven't, because again, we need to make this element 0. That would be our last element. So now what we have to do in the case of pivoting, what we need to do, we need to check now that in this particular section, sorry, in this particular column, which element is of maximum magnitude. So is it minus half or is it 7 by 2? Minus half absolute value is 0.5 and 7 by 2 absolute value is 3.5 because it is a positive number. So which one is the greatest? 7 by 2 is the greatest one, right? So what we have to do, we have to, this element is of maximum magnitude. So as A43 is of maximum magnitude. So interchange the rows R3 with R4. So let me do it quickly. So this would be, I'll just write it here. 2, 0, 0, 0, minus 1, 2, 0, 0, 3, 0, 7 by 2, minus half, 0, 3, 7 by 4, minus 5 by 4, 3, 1, 7 by 4, 3 by 4. So this is what we are getting as our final matrix after interchanging the rows. Now, when we have interchanged the rows, now you will be considering as take this as the pivot element. Okay, so take A33, which is 7 by 2 as the pivot, and make A43 0. You have to make that 0. So what would be the elementary row operation in this case? A43 upon A33, row 3. So that is nothing but A43 is minus half, so it becomes plus half upon 7 by 2, right? So I am getting this as 1 upon 7. So I'll just write 1 upon 7 times R3. So you could refer to this. Okay. Now, so my element, after doing this elementary row operation, I am getting this as 0, 0, minus 1, 2, 0, 0, 3, 0, 7 by 2, 0, 0, 3, 7 by 4, 3, 1, 7 by 4. Okay, for these two elements, just put in the values. So this would be minus 5 by 4 plus 1 upon 7 into 7 upon 4. So I'll be getting minus 5 plus 1, and that's minus 4 upon 4. So it becomes minus 1. Lastly, this is 3 by 4 plus 1 upon 7. And this is 7 by 4 again. So this is 3 plus 1 upon 4. So that's 1. So this is my final values. Let me just erase this. So this is how you can solve a 4 cross 4 matrix and 4 system of linear equations using partial pivoting. So the first step is over. Partial pivoting is applied in the first step, that is the forward elimination only. In the backward substitution, you don't apply the partial pivoting. So the backward substitution, that is the second step of the Gauss elimination, remains the same. So there is no difference in that. So now you can, we rewrite this as the matrix, that is 2, 0, 0, minus 1, 2, 0, 0, 3, 0, 7 by 2, 0, 0, 3, 7 by 4, minus 1, sorry, x, y, z, w, and we are getting 3, 1, 7 by 4, 1. So using the backward substitution means you will be going like this, and it would be 0x, 0y, 0z minus w is equal to 1. So I am getting my w as minus 1. This is my first unknown value. Now the next would be 0x plus 0y plus 7 upon 2z plus 7 upon 4w is equal to 7 upon 4. So I am getting this as 7 upon 2z, 7 upon 4. This becomes minus, so this is plus 7 upon 4. So this is ultimately, when you solve, I'll get z is equal to 1. Then the second equation, this third equation, 2y plus 0 times z plus 3 times w is equal to 1. So 2y minus 3 is equal to 1. So I am getting my y as minus 1. So sorry, not minus 1. This is 4 upon 2, that is 2. Lastly, this equation, the fourth equation, 2x minus y plus 3z plus 0w is equal to 3. So 2x minus 2, 3z plus 3 is equal to 3. So this becomes 1. So 3 minus 1 is 2. So x is coming out to be 2 upon 2, that is 1. So ultimately, or finally, we are getting these values as my solution. So also we can write thus the solution of the equation x, y, z, w would be 1, 2, 1, minus 1. So this is our solution using partial pivoting. Very easy to understand. We have another questions with I'll be taking in the next lecture as well related to partial pivoting. So stay tuned to my channel, and we'll meet again. Thank you.